So let's talk about how to test combined publishers. Here I'm working in a test target so we can explore some different strategies we can use when testing combined publishers. So we're going to start with a function to test a simple publisher. And it's worth noting that some of the strategies we're going to use are just going to essentially be contrived examples where we set up something in the test and then we test that it happened. And this is really only useful when exploring combine and testing that your assumptions are correct. But it's important that we understand that we don't need to test combine itself. We should assume that it works because that's Apple's responsibility. And if our assumptions are wrong, then the test can help us validate that. But I don't want to suggest that we need to test every little publisher or every little operator that Apple ships to test that it's doing the right thing. So we're going to explore some contrived examples here, and these will serve as ways of exploring combine and validating assumptions and learning. But in your own shipping code, you're going to want to focus more on testing your actual logic and the outcomes that you get out of using combine. So we're going to take a look at that in another video as well. But let's start by testing a simple publisher. So I will create a publisher of integers, 1, 2, and 3. And that will give us our publisher. Then I want to get some values out of that. So we're going to create an array of integers that we can then do some assertions on later. And then we also want to check what kind of completion we get. So I'm going to create a subscribers.completion, and this takes the type that we are going to be getting. Actually, the completion event, which will take the error type. So in this case, the error type or the failure type is never, so we can do that. So now we just need to call pub.sync, and we'll be able to get the value and the completion here. So for the completion, we will say completion equals $0. And for each of the values, we can say values.append $0. So because this is a publisher that will just emit all its events and complete right away, this is pretty easy to test now, because now we can say xct assert equal and make sure that 1, 2, 3 equals values. And I'm always questioning which one these should be. I think it should be actual, comma, expected. So I'm going to put it in this order. So I'm actually going to make this test fail first because I want to see it fail. So we can run the test by clicking this little triangle here, or we can hit Command U, and that will run all of the tests in this target. So you can see now that it says 1, 2, 3 is not equal to 1, 2, 4, which is true. So we'll do that. And then we can xct assert not nil on the completion to see that the completion was actually set. And if we wanted to, we could also assert xct assert equal that the completion is equal to finished. So this is the basic setup for testing something that is essentially synchronous. It just happens once, and we can then sort of intercept the values and store them in variables to do our own assertions on them. Let's test another example. In this case, let's test the filter operator. So here we're going to start with another publisher, which will be 1, 2, 3, 4, 5, and 6. And we're going to have the exact same setup here. So I'm just going to copy this down here. And what we're going to test here is that we can filter the if $0 is a multiple of 2. So now we expect the values to give us 2, 4, and 6. And if we run that, the test succeeds. So it's important to note that this is essentially testing the filter operator, but we are exercising this block, which is our custom logic. So in this case, it does make sense to test that we have implemented the filter operator correctly. Next, let's do a test here where we'll say, test future, and we will first create a publisher that will be a future. And in this case, we're going to have a promise in, and that our promise will have a success value of OK. So this is going to be a future string. So we can do future string never like that. And let's see, what I want to know is when this gets called. So we can have essentially a variable here called call count. We'll set it to 0. We'll say call count plus equals 1. And here I want to XCT assert that the value is 0. So we'll say call count is 0. Now, then I want to subscribe to this. So we'll say pub.sync, and then we'll get back the value. In this case, we can say var value is an optional string, and we can say value equals $0. And then XCT assert equal that the value is equal to OK. So we run this test, and we will see that it fails. It fails because our initial assumption here is that this future doesn't get called until we subscribe to it down here. So this ends up being incorrect, an incorrect assumption, because as we've learned earlier, that future will execute its block immediately, and at that point emit the value downstream. So our call count is going to be 1 at this point, and if we want it to be 0, then we need to wrap this whole thing in a deferred. Now we can run the test and it succeeds. So what happens if we talk to this multiple times? So in this case, let's have value 1, and we'll also have value 2. And then we'll do the same thing here. This one will be value 1, and this one will be value 2. And we can assert that both of them are the value OK. And then at the end, we could say XCT assert equal that the call count here was maybe 1. If we expect this only to be called once, then we can see that in this case, this will fail because when you subscribe to the deferred, it will execute the block. The block will wrap in a promise and call this. And so we can see that this is being done multiple times. And so if this was some sort of complex operation or expensive operation that took some time and we wanted to reuse those values, we could explore using the share operator. So what I could do here is say that I want to share the results of this with any other subscribers. Now, the important thing to know about share is that when I'm setting this up, so we can see that publisher at this point is a share publisher. When we subscribe to it, it's going to call this once and then share the results with other subscribers. So if we run this test, we can see that it seems to work. It called it once. We can move that up just to verify that that did get passed. And value 2 ends up being nil. And that's because it doesn't hang on to the value. It did its first subscription. It emitted the value to all of its subscribers, which was just the first one. And then the second one doesn't get one. It just gets a completion event. So this isn't really what we want. If we want to essentially share this, we need to wait until we've set up everything before letting this kick off. And so this is where we can use make connectable. So connectable publishers will wait until you connect them in order to kick off any work. So that gives us a chance to then hang on to both of these. We will actually need to hang on to these as cancelables. So we'll say C1 and C2. And at this point, we can say publisher.connect. And this will allow, this also returns a cancelable, by the way. And this will allow it to, at this point, do the connection, which will emit all of its events to all of the subscribers. So in this case, with the connectable, we should see that this test now passes and it only called the block one time. So there is a bug that you'll see if we're using this trick of just ignoring the value. We'll see that these things get released right away. And so there actually is no, by the time it gets to Pub Connect, those subscriptions have already been released. And I also don't like that this ends up producing a warning. So one thing I do when testing combined stuff is I'll usually set up a cancelables here, which will be a set of any cancelable. And then I'll make that force unwrapped because we're going to set it up here in the setup function. It's important to, when you do setup, there's two of them, and it's hard to tell which one. This middle one will be the instance setup. The first one is actually the class setup, which is not one we need to use. It's important also to always call super setup because the parent class, in this case it doesn't matter, but if you inherit from your tests, for instance, if we wanted to inherit from combined test and have cancelables set up for us automatically, that would certainly be a valid choice. And anybody who inherited from that class would make sure they would have to call super setup. So it's a good practice to be in to make sure you do that. So at this point, we need to create a new set of any cancelable like this. And then I'm also going to do teardown and make sure to use the second one here that's an instance teardown. Also call super. And here I want to set cancelables equal to nil because I don't necessarily want to wait and have those subscriptions hang around until the next test is run where this is reset. So this, sets it up and this cleans it up and this seems balanced. So now we can take that example and just say store in cancelables like this, and this will eliminate the warning and allow this to still work. Let's do one more test here, and this will test values then failure. So say in this example, we'll have some sort of test error, which is an error like this. And we want to test that we get a certain number of values and then fail. So the easiest way to do this is to use a subject. And so I will create a pass-through subject of type int and test error. And then what we can do is assert that we get some sort of values like this, and also assert our completion, which will be subscribers.completion of test error, and make that optional. So then we can say subject.sync, and we will get all of these values. Here we are given our completion in, and we can switch on that completion. And in the case of finished, we want to XCT fail here because we should never be finished. We should get an error. Expected to get an error. And in the case of failure, we want to test that we got that particular error. XCT assert equal, and we can say error.localizedDescription equals test error.localizedDescription. For instance, if we want to test that these errors are indeed the same errors. So that tests those two things, and then we get our values, and we can say values.append $0, and at the very end we can say XCT assert equal, and here we can say that the values are equal to 5, 6, and 7. So it's worth noting that we're testing our values down here, but we're testing our completion in here. And if this subject never completed, then these assertions would never run, and we'd have a false positive, or false test passing, when in fact, if it doesn't complete, that would be an error because we're expecting that we get a failure. So that's why I like to move these out into, say, completion equals $0, and we will just move this up and make it a little bit more tidy. We can store that in our cancelables. And now we can take that switch statement and move it out here, and this will make sure that we get called. However, we have to deal with the fact that this might be nil. And so if we fix this and add the case none, we can say XCT fail. Another way to deal with this is to use XCT unwrap, and this is a throwing value. So what we can see about XCT unwrap is that this will give us back an actual t. So we pass something that gives us an optional t, it'll give us back a t, and if it doesn't exist, then it'll throw an error. We want the throwing error to fail our test, so we can just make our test a throwing function. And now we can say let comp, or actually we can just put that in line here, XCT unwrap, we'll have to use try here, XCT unwrap completion, and now we can avoid this case here. And I find that XCT unwrap can actually make dealing with optionals quite a bit easier because downstream you don't have to constantly deal with the optional part. You can just deal with the unwrapped version. Okay, so we've set up our test, but obviously our subject isn't being interacted with at all. So you can see our first test fails here because we didn't complete. So we could say subject.send completion finished, let's say, and then we should see a different failure. Here we expected to get an error. And then here we could say, okay, I want you to fail with test error. And now we can see it fails down here because we never sent those values. So subject.send 5, 6, and 7. And this one can be switched to a let. And so this gives us an example of how we can kind of set up the timing or the actual sequence of events. So first you get this value, then you get this value, then you get this value, then you complete with a failure. And we've tested every bit of this interaction. So this gives us a few strategies we can use for testing, combine, and validating our assumptions. Okay, let's talk about how we can test timing. So here we have a timing test which inherits from XCTestCase. And like I alluded to last time, sometimes I think it can be helpful for us to create our own base classes here. So I'm going to create a combined test case base class. And we're going to put our cancellables in here. So we'll do a set of any cancelable, force unwrap, and then, or implicitly unwrapped optional. And then we will use super setup here. And then I'll set it up. Cancellables equals a new one. And then for the teardown, super.teardown, and cancellables equals nil. So this is what we need to do to sort of reuse that. And now we have a base class that we can use, combine test case. And if we inherit from that, we automatically get our cancellables that we can use to avoid having to do this boilerplate in every test that we create. So here I want to do a test where we are testing a receive on. And what I want to do here is, let's say we have a value like just 1, and I want to say receive on, and we'll use dispatch queue.main, and that will give us our publisher. And then we can get a value that we expect and say pub.sync and store the value into there. And then we can run XCT assert equal and assert that our value is equal to 1. And here we'll call store in cancellables to allow this to stick around for a bit. So if we run this test, we can see that it ends up failing. And here we can see that our assertion failed because this value is nil. And that's because receive on essentially ran dispatch queue.main.async before essentially delivering any values from the upstream publisher, which means that everything in line here is single threaded. It will wait until the end of this essential execution, and then it will follow back with any of the async blocks that were enqueued on this sort of in the next run loop cycle. And we've already run our assertion by that point. And so if we comment this out, this test passes. So how would we test this particular example? Well, one would be for us to create an expectation. And so this expectation is part of XCTestCase, and we can say, give it a description like publisher finished. And then we can, on our publisher here, we can say .handle events. And in this case, we just want to receive the completion event. We don't care what it is, but now I can say exp.fulfill to tell the test system that this expectation was fulfilled. So that's two parts of the same sort of thing. We create an expectation at the beginning, and sometime later we tell it to fulfill it when this is completed. But then we need to tell our test to wait for those expectations with a given timeout. So say I'll wait for 1 second, and I don't need any kind of special handler. If it times out, we'll just print a generic error. So in this case, when we run it, now it should work, but I have to move this assertion for after this line here. So we'll wait for the test or the publisher to finish before we assert our value. So this allows us to get over these sort of simple cases like where we are jumping onto a different queue or jumping onto the same queue, but just in an asynchronous fashion, and wait for those values before we run our expectations. Let's see another example of that. Here I'm going to say test delay. And for this one, I want to have a publisher that say takes some numbers like this. And for each one of these, I want to emit the element and then have a short delay before emitting the next one. So if we take that and we flat map this into another series of publishers, and I say just $0, so now we've got a publisher with just one of those elements, we can attach delay for seconds 1, and then we need to pass in the scheduler dispatch queue.main. So we can do something similar here where we can have our values maybe, or maybe a count of how many values. We could do that. And let's go ahead and subscribe to that. So we'll say pub.sync. We can say count plus equals 1. And we can store this in our cancelables. And again, we want to wait for this the same idea to finish. So we're going to say create an expectation and then call handle events, receive completion. We don't care about the completion, but we can say exp.fulfill. At the very end, we'll wait for expectations with the timeout and nil. And then here we can say xct assert equal, and we assert that this thing emitted 3 elements. And if we run this one, we can see that it succeeded. If we look at the output here, we can maybe print it out. Here we'll print $0 like this, as well as adding the count. And let's go ahead and run this one again so we can see the output. And you can see that in the output, we did get a delay here, but then it just emitted each one of these. And that's because FlatMap is allowing it to subscribe to all of the publishers that are returned from this at the same time. We can set max publishers equals a maximum of 1 at a time, which means that it'll subscribe to the first one and wait, and then subscribe to the second one and wait, and subscribe to the third one. So if we run this one, we will see our test failed. And that was because it waited 1 second. We got our first output, but then the timeout happened. So we need this to wait at least 3 seconds for us to finish this test. And if we look at that, we get 1, 2, and 3 like that. And we probably need this to be a little bit more than 3 seconds because our timeout actually fired prematurely. And we get 1, 2, 3, and then it's done. So this is the type of thing that is kind of brittle in your test. In our case, we have a very specific 1 second delay, but it's not exact. And so if we're saying wait for 3 seconds, if I had said 3.1 seconds, it probably would have worked. But this is the type of thing that is not great. And it's even worse if I change this publisher to, let's say, take a range of 1 to 30. Now, not only will this test not pass because our timeout is now not balanced with the number of items in this publisher, but now if I do want to do this, it's going to take 30 seconds for this to complete, and that's just not great for tests. We want our test to be really fast, and so there are a couple of things that are not great with this type of testing. So the crux of the issue here is that we have the scheduler here, and the scheduler is both responsible for where this work runs and also when it runs. So in this case, it's just a simple async, so it'll happen on the next run loop. But in this case, we're actually delaying, so it has a concept of time as well, and it knows when to schedule that work. And so in essence, those are the 2 main components of the scheduler protocol that we have to use here. And most of the time, we're going to be using dispatch-queue.main, but if we want to control these things in tests and not have to wait, for instance, or maybe be very specific in control of our timing, we could benefit by having our own scheduler. So there are some community schedulers around that can help us with this. And one of those is Combined Schedulers by Point.Free. This is a Swift package. So we can go over here into our project to Swift packages, and we can add this GitHub URL. It'll grab the Swift package out of that, and we can add it to our project. Okay, so now that we have this dependency, we'll go back over to our tests, and we'll import it at the top, Combined Schedulers. So Combined Schedulers comes with a few different handy functions. One of them is something that we can use here called the immediate scheduler. There's something immediate scheduler.shared we can use. Alternatively, we can use dispatch queue.immediate scheduler like that. So if we want to use the immediate scheduler, we can avoid this expectation idea. In fact, I'll just uncomment the wait. We need to get rid of the fulfill there. So the idea here is that the immediate scheduler just executes the block as soon as it's scheduled. It doesn't wait for a run loop. It doesn't do it asynchronous. It just executes it right there in line. And so this can be really handy during testing. If we do the same thing over here and use dispatch queue.immediate scheduler, we can see that this one will allow our test to get all the way to the end without timing out. If we change our count here that we expect 30 elements, we run it again, and it succeeds immediately. We can see that it did output all the values. It went through all the motions, but we didn't have to wait for any delay. So this is really great, except for the case where we want to test for this delay. So as an example, let's say that this was in a function. In fact, we can do both of these in a function. We'll imagine this is some sort of library code in our application. And so we've got a function here that is going to give us a simple value publisher. This is going to be any publisher of int and never. So we're going to take this code here, the just one and receive on. And so what we're going to do here is just return this, and we need to call erase to any publisher. And now this guy can say, I just want to call simple value publisher. That's going to be the publisher that we're going to be working with. Now, we don't want to use this in our application, right? We wanted it to be on the main queue, but during our testing, we want to be in control of the scheduler that it uses. So that leads us to the idea that we need to pass in a scheduler. And a scheduler is a protocol. So we would have to do something like this, where you pass in or declare some type of scheduler. And here we can use that S as our scheduler and then use that inside of here. So now we've injected this dependency, and this is actually a decent idea of injecting sort of your external world dependencies, things like calendars, things like clocks and locales, and things on the system that are outside of your control normally during a running example. But when you want to test them, you want them to be under your control. So this does sort of fall in line with a dependency that is good to be in control of and inject this dependency where you can. So at this point now, our library or application code is generic over the scheduler we're going to use. And so here we just need to pass in a scheduler, and I'll pass in dispatch queue.immediate. Okay, so at this point we can run our test, and our test still succeeds, and we no longer need this expectation because we're telling it just run it right away. And I just want this test to be a little bit simpler, and not having all this sort of extra test cruft in there, I think is a benefit when we can use it. Now let's do kind of the same thing on the delay side. So let's say we have some application code we want to test here, and this is a delayed publisher, and it's going to take some values here. And we could make this an array, but as you saw, we used an array and a range. So let's make this generic over some sort of sequence. So this will be some sort of sequence type, and that will be some type of sequence. And this will return an any publisher of that sequence's element. So now we can say, okay, just give me some sequence. And then I need the scheduler as well. And it does get to be a little bit annoying that I have to be generic over the scheduler type, but I don't really care what type it is inside of here. So just passing in an instance of S there, it means that we have some extra kind of generics cruft that we don't really care about. So because of that, Combined Schedulers actually comes with a type erased version called any scheduler of, and I need to tell it what type of scheduler it is. So this is going to be a dispatch queue type of scheduler. Now the reason is there's different types of schedulers. There's dispatch queue, which has its own notion of times and what the notion of seconds and things like that are. Operation queues are different and run loops are different. So this says I want to get any scheduler of the dispatch queue family, and we can use that. We need to say that we never fail here. Okay, so now let's go down and grab our delayed publisher code. So we're going to take the publisher for that, bring that up into here. This is going to be values.publisher. Then inside of here, we're going to get just the value, delay for 1 second. And for the scheduler here, we now use the scheduler that was passed in to us. Then we can call erase to any publisher. And now we have a delayed publisher for a given sequence. It would delay 1 second in between each one of the iterations of this element and then complete. So now when we want to go test this, we're going to say delayed publisher for the values 1 to 30. And then for the scheduler, we can use dispatch queue.immediate scheduler. And then I need to call erase to any scheduler to get the type erased version. And so this is basically what we do. In our main application code, we use the main queue and erase it to any scheduler. And in our test, we use immediate scheduler. But if we want to use the immediate scheduler, this does allow our test to succeed and succeed essentially immediately without having to wait. But this also sort of skips over the fact that we wanted to test that there was a delay here. So if we want to do that, we need to use something a little bit different. And so for that, I'm going to create a test scheduler. We'll just call it scheduler. This will be dispatch queue.test scheduler. So inside of here, we're going to use that scheduler, erase to any scheduler. So that's what we pass in here. And at this point, it's frozen in time. If we run this, we're going to notice that it times out without emitting any values. So it didn't emit a single value and it timed out. And that's because time is frozen. Time is not advancing at all. We said wait 1 second before emitting the element, and it's never going to emit the element because 1 second never passed. So we need to specifically tell it that a second passed. So what we can do here is down here, we can say scheduler.advance, and this will advance by a given stride, which I believe is 1 second. So if we do that, then we should XCT assert equal that count is now 1. And see if this assertion passed. We should still get our timeout and the rest of it. And so, okay, let's make sure, let's say advance by 1 and check that out. Okay, so now this assertion passed. So I'm not quite sure what the stride is. It says by the given stride. Looks like initially it is 0. So it does not advance the time, but it does cause the scheduler to execute any units of work that are waiting to perform right now. Okay, so this makes sense. So if we had like a, dispatch queue.main.async or whatever, and we just want to advance it so that it will queue up all of that work and execute it, that's what advance would do. But we're going to advance by 1 second, assert that it's 1. Then we can advance by 1 more second and it'd see that it's 2. And then maybe 10 more seconds would make it 12. And then if we go for, say, 20 more seconds, that is beyond the 30, so we expect there to be 30. And at this point, we can delete the expectations and the waiting like that. And let's go ahead and run this and see if we get a good result. Okay, so this is testing specific intricacies with timing without having to actually wait. As you can see that our test executed in 0.003 seconds. So this is the type of test, performance that you want, but we're not giving up the ability to test and control time by just using this test scheduler instead of iReal1. So now that we've seen a few testing strategies for testing combined publishers, let's see how we can use that in a real app. So here I've opened up the example app sign up with view models example that we created earlier. And as you can see, there's some sign up form rules that we had, and we implemented these one at a time. And this actually serves as a good reference for what we might want to test. So I'm going to go over to our project here, and we're going to create a new test target. So we'll use unit testing bundle. And I'm going to rename this one to sign up view model tests. Now I also want to create a combined test case helper that we can use for a base class. We'll import combine and XCTest. And this will be our base class, which inherits from XCTestCase. So inside here, we're going to have our cancellables, which will be a set of any cancelable. And we will use a implicitly unwrapped optional. And that's because we want to set this up in setup. And then in teardown, we also want to do the same. So now we have a base class that not only will set up our cancelables for us to make our tests a little bit easier to write, but we also have a place that we can write combine specific helper methods. And so we want our test to inherit from combine test case. So in here, we're going to just delete the content of this file, and then we're going to paste the rules that we have so we know what we're going to be testing. So the system under test is our signup view model. So we'll create a reference to that signup view model. And for us to do that, we will have to use testable import and then the example app signup, which is our main app target, which contains that view model. We'll also need to import combine here. So over here in the setup function, we will call super setup, and this time it is critically important that we do this so that we get our cancelables from the superclass. And then here we can create an instance of our view model and make sure we're not using the class func there. Okay, so the first thing we want to do is test the valid email address. So we'll create a func test valid email. And what we want to do here is take our view model and we want to give it an email address. So we can say email equals foo. And I want to assert that this is invalid. So what is going to happen when we assign this is it's going to actually emit our valid email address publisher is going to emit a value. So we'll have some sort of valid email signal here, which at this point will be a Boolean, which will be nil. And then we can take our view model and we can subscribe to the publisher valid email address. So this is a valid email address, any publisher of bool and never. We can sync and set valid email signal equals to that value. And then because this is a cancelable, we can store this in cancelables. So now when we trigger this, we expect that this valid email signal should get a value and it should be false. So we can say XCT assert false valid email signal. Now at this point, valid email signal is an optional, so we could also use XCT assert equal and then say we expect valid email signal to equal false. And this is because it's optional, and because it does this, we can compare the two like this instead of just saying XCT assert false. Okay, so far our test is working. Now what we want to do is assert that if we set a valid email address like foo@bar.com, that we get another signal and it is true. So this time we can do that. Now at this part, we're testing two different things. So I'm actually going to split this apart into two different tests. We'll say test invalid email and then test valid email. So this first one will be foo@bar.com and we expect it to be true. And then the second one will be invalid. Okay, let's run both of these tests. And both of them succeed. So we have this pattern of setting up an optional signal, which will be the value that we expect. And critically, it is important that we make these optional so that their default value is nil and we're not testing any kind of default that we put in here. For instance, if I were to put false here and we never got a signal, this test would still pass. So it's important to use the optionals there. Okay, now let's move on to the next one, which will be password. So we'll test a valid password and an invalid password. So testing a valid password, and here we'll say valid password signal is an optional Boolean because our publisher is a valid password publisher, which produces Booleans. So here we can sync and say valid password signal equals $0, store that in cancelables, and then we can set our view model.password equal to, and let's use combine Swift1, which should be a valid password per our rules. And then we can XCT assert equal that the valid password signal is true. Let's do the same thing, but for an invalid password. Here, I will say just combine, which should be too short. And this one should be false. So we'll run the valid password case, and that succeeds, and the invalid password case, and that succeeds. So at this point, you can see this pattern that we're using where we expect that we have a signal, we do some work, and then we trigger it, and then we assert. So this is kind of arrange, act, and assert. And this is kind of a ideal test structure for most tests, where you kind of set up the environment, then you act on the environment, and then you do your assertions at the end. And you can see that basically all these tests are exactly the same, with the exception of what type of signal we're expecting, what is the publisher, and what is the value we're doing. So we can actually extract a helper method in here to make this type of stuff a little bit easier. So let's go over to combine test case, and let's add a function that we can call called assert publisher. And we can pass in some publisher here. And publisher is a protocol, so we'll have to pass in some P that is a publisher, publisher P. And then we can say produces and some sort of value. So we say produces value, and here we can say P.output. So what I want to do, let's actually rename this to be expected, so that later when we are doing our assertion, it makes it a little bit more obvious. And then we need to pass in sort of what action we're going to be taking on this publisher in order to produce that output. So I want to take a block here, and this will be a block that takes nothing and returns nothing. And now we can sort of set up our test again. So this will be arrange, we'll have act, and we'll have our assertion at the end. So we'll start by getting the value that we're getting out of this will be an optional P.output. Then we can subscribe to this. So we'll say publisher, and this time we'll say sync, we'll say value equals $0, store in cancelables. Now for us to ignore the completion event of our sync, we're going to have to make sure that publisher is a never publisher. And in our case, it's fine for us to do that for now. So we can just say P.failure is never, but we may want to test publishers that can fail, in which case we'll have to revisit this decision and figure out what we want to do when we're asserting some sort of output. Okay, so our act is just going to be invoking whatever block was passed in, and then our assertion here is going to assert that our value that we got is equal to the expected value. Now we're saying that value needs to be equatable, so we need to actually add our conformance here where P.failure is never and P.output is equatable. Okay, so now we have this helper function which will allow us to test a single value, but it is important to note that our publishers don't always emit their events immediately. Sometimes they may need to go do something asynchronous. There may be a delay. It may go fetch something from the network. And so for us to set up the publisher, then act on it and immediately test the assertion doesn't really make sense for those cases. So for us to work around that, we can use the standard XCTest behavior to test asynchronous code where we set up an expectation. So we can say expectation publisher completed or received a value. And then we tell the test to wait on that assertion, or wait for that expectation. And it is really important here when you're dealing with helper methods to only wait on the expectations that you make, so that any other test expectations that are created outside of this helper don't affect this. So here we're going to say, let's just wait for 1 second, and then we can do our assertion. So now we have to figure out when are we going to fulfill this expectation. There are two cases here. One of them is when this completes. So we can say handle events, and here we can say receive completion. And this will give us our publisher's completion event. And if it completed, we want to fulfill this to say that the publisher completed. And in fact, in this case, I'll just say publisher completed here. So we want to make sure that if we get a value and then complete, it fulfills. But we also want it, if it just completes without a value, that it'll fulfill this as well. But not all of our publishers are ever going to complete. And so we also need to handle the case where a publisher just emits values forever. And in that case, we want to fulfill the expectation here as well. So we'll handle both cases where a publisher can just end immediately or the publisher emits a value. If it never emits a value, then it's going to wait here for the timeout and fail right there. Okay, so we have a bit of a problem here is that our test will complain if we fulfill it twice. So we can change our expectation to say assert for overfulfill equals false. So that if it were fulfilled here, then this one won't throw any kind of error. Okay, so now we have this assert publisher helper. And now let's refactor our tests. We have 4 tests and they're actually going to get a lot easier. Here we can say assert publisher viewModel.valid email address produces the value true when we do this. And I can just move this line here up into that block and delete the rest of this code. Let's run this one test. And it still works. And if I cause the test to fail by eliminating the @ sign, the test fails. Okay, let's continue our refactoring of the rest of these tests. We're going to do the same thing here. Assert publisher viewModel.valid email address produces the value false for this block. And we can actually clean this one out to eliminate that. And if we wanted to, we could test the different cases to see if it has an @ sign or not, missing a dot or whatever our rules are. But this is a broad stroke test that will cover our case. Now for valid password. Assert publisher viewModel.valid password produces the value true for this block where we mutate the password. And then we have the exact same thing here, but we expect the value false for the value combine. Let's run all of these tests to make sure we're still green. And we are. Next, let's test the password matches its confirmation. So here we want to assert that our publisher viewModel.password matches confirmation produces the value false, then the value true. So what I want to be able to do is say, let's set viewModel.password equal to combine Swift1, and then we'll do the confirmation, password confirmation equals combine Swift2. So we want to assert that it's false here, then change viewModel.password confirmation equal to combine Swift1, and then it'll be true. So we want that to produce false and this to produce true. Now, unfortunately, the way we wrote our publisher assertion here is that it can only test the final value that comes out of this. So I think it would be nice if we could specify a sequence of values. It produces false and then true. So if we do that and we go back over here, we can change this expected p.output to be a sequence. And so you can pass 1 if you want, or you can pass in multiple. In that case, p.output is actually going to be an array. So we'll change this to an array with no items in it. And then here we'll say value.append $0. So we'll just append each of the values we receive. And now we're back to the same expectation that the values will be exactly the same array that we specify. So let's run this previous test to make sure that the existing ones still work. And they don't. In this case, you can see false, false is not equal to false. And this is because when we go into it, this password has a value already. And when you subscribe to it, it's going to emit the event of the value that it has. And this is an invalid password. So in this case, there are 2 solutions we could choose. One of them, we could drop the first value out of this list. I think this is an okay solution, but we would have to essentially make this happen everywhere. We'd have to copy and paste that solution every time we use this. So I think a solution that might be better is for us to refactor this and to only call the one that has an array if there is a single item. So maybe we could say produces exactly with this expected output, and this one will do the array version. And then this one will be a single one where it just does one version. Now there's a lot of duplication here, but I think that keeping these things malleable is fine for now. And we could sort of figure out what the proper interface should be before we sort of lock this down and eliminate all the duplication. But for now, we have two different ones. We have an assert publisher, which produces an exactly, and that one will collect all the values and make sure they're specifically what you want. Or this one asserts that the final value is the expected value. So at this point, we can say produces exactly false and true. And this one just produces false. So now this test passes. And if we go over here, this test does not pass. And that's because like we had before, our password matches confirmation is starting with their initial values. And because the password and password confirmation are both blank, they do match initially. So we get a true right away. Then I change password to be something else right here. And so we get a false. I change password confirmation to be something different, and so I get another false, and this is the first one that I expected to happen, and then true. So what we really want to do is just ignore those first two values. So in this case, I'm going to say drop first two to make sure that we're just testing this particular part of it. Okay, so now we have test password matches confirmation. So I'm going to leave a few more of these tests as an exercise for you to finish on your own. But what I would like to do is test the final sort of logic of this is testing the form is valid. And this is going to be a larger test, which I think we're going to go back to the sort of more manual approach because I want to test the specific interactions. So we're going to go back to this idea of testing this valid signal. Then we're going to get the is valid publisher. We're going to subscribe to it, set the signal to that value, store in our cancellables. And in this case, we can specify some setup here for the view models email equals some invalid email. Password should be some invalid password. The password confirmation should be invalid too, so it doesn't match. And then viewModel.agree to terms is false. And this is the default, but the idea is we're setting up a completely invalid form. And I want to make sure that the last value we got from the is valid form signal is false. Then I want to make all of this a valid form by saying viewModel.email equals tcook@apple.com. Password is going to be combine Swift1. We'll do the same thing for the password confirmation. And then viewModel.agree to terms equals true. And for completeness, you could assert that every step of the way it was false until the very end, but I think that this is fine here. Again, I'm just testing kind of in broad strokes to make sure that this matches our expectation. And now we have a passing test. So we've actually tested quite a bit of logic in our application. And the reason is that we have extracted most of this logic into this view model, which has no bearing on the UI at all. It doesn't really depend on anything on screen. And so our tests become a lot simpler, and we can test the interaction. We can test our logic of our form without having to ever touch any text fields or anything like that. And so I think this is a good strategy here, and this is a great place to start testing because testing these simple publishers is, as you can see, pretty easy to do. Additionally, I think it sort of reinforces the fact that creating smaller publishers like these, where you can test them independently and then later combine them all into one bigger pipeline, makes a lot of sense because that way you have a smaller granularity and you can test each individual piece on its own. Okay, let's take another look at how we can test a real application. In here we have the weather application that we created back in Module 8. And specifically, I want to start by testing the add city flow. And if you recall, this is where we are searching for a city. It uses MapKit to autocomplete cities. And then we tap on one, it geocodes it and adds it to its list. So In order to test this, we're really going to be testing this view model, the add city view model. And that way we don't really have to touch any UI. We can just sort of touch the interesting parts of this to make sure that it works the way that we intend. Now, if you take a look at this add city view model, it has some pretty heavy dependencies. The first of which is this MK local search completion and MK local search completer. The second is CL geocoder. Two of these things are system level dependencies that are provided by Apple that are difficult, if not impossible, for us to control for our own testing. And when we have things like this, that means we're going to have to break this dependency or decouple the dependency on this concrete object and instead program to an interface that we do control. So I'm going to start by adding a new group over here in WeatherKit, and we're going to call this local search. And inside of here, we'll create a new file, and I'm going to call this local search completer. We're also going to need a new file for the model object that's going to come back as the results. And for this, we'll call this local search completion. So for this one, we're going to have a public struct of local search completion, and we will make this identifiable, equatable, and hashable. We'll create a public let ID equals a new UUID so that we can get our identifiable conformance. And then we will have a title and a subtitle. And in order for us to create these, we'll have to create another public initializer here for title is a string, subtitle is a string, and assign them. Okay, so now we have our model object that we can use, and now we can create a protocol here, a public protocol that we will call local search completer. We'll have a method on here called search with query, and then a results property, which will make an any publisher. So we need to import combine here. Any publisher of an array of local search completion. And we'll say that it never fails for now. So this gives us our interface that we can use. The next step for us is to create a MapKit version of this. And so we'll call MapKit local search completer. And this one will import combine, and we'll also import MapKit. So this type is going to be a public class, MapKit local search completer. It'll be an NS object because we'll need to use the delegate, and it will implement the local search completer protocol. Now we're just going to have this wrap the internal completer, which will be MK local search completer. And we can have it deliver its results through a subject. So we'll say results subject is a pass-through subject. And here we can do an array of MK local search completer and never. And we'll initialize this right away. And then we can provide our results, which is going to be the conformance of our local search completer here. And we just need to initialize that to something. So let's create an override of the initializer here, which will assign results to be our results subject. And we want to map the results that we get from that. And if you recall that this is the combine map, which is going to give us an array, and I want to return a new array. So we'll say results.map inside of here, which is going to map each result into a local search completion with a title and subtitle. So here we can use r.title and r.subtitle. And I think this needs to be completion, so it's the model object. And then after we're done with that, we can call erase to any publisher. Now that we have our results publisher ready to go, we can call super.init. And then finally, we can set the completer's delegate to self. That means we're going to have an extension on our MapKit local search completer that it conforms to the local search completer delegate. Here we can say completer did update results and completer did fail with error. In this case, we'll just print out the error, but we're otherwise not going to deliver that downstream. And then if we get results, we can take our results subject and send it our results, which are going to be completer's results. Now the last thing we need to do is add our search with query method, and I will just move this down here. Search with query is going to set the completer's query fragment equal to this query. So we've basically provided a simple wrapper around what would otherwise be a MapKit search completer. So because we've done that, and we have this new model object we can use, local search completion. If we go back over to our weather app inside of Add City, our view controller was using this results type. And we can actually delete that now because we can just use the local search completion because it's a type that we control already. So we'll need to update this to be local search completion. And then over here in the view model, we'll have to do something similar. Instead of being an array of add city view controller dot results, this is now an array of local search completion. And again, right here, we'll have to create local search completion like that. So now we need to decouple this from the MapKit version. So if we just get rid of that MapKit import, that can aid us in our path. So we're going to need some sort of search completer. And we already have an example of using this world struct right here. And we can pass that in here. So this will be our search. We'll call this local search. Is some sort of local search completer. And when we initialize the current state of the world, we'll say local search is a MapKit local search completer. Okay, so we'll have some build errors to figure out here. So this will change to just be local search completion. And now for the search completer, we can just change this to be a computed property. This will be a search completer, and this will be current.localSearch. So this is actually going to end up being a little bit simpler because we can get rid of that. And in fact, let's just change this name to local search as well. So when we set our search term, we'll set local search.searchWith, and we'll pass in that search term. And if it is nil, then we can pass in an empty string. So at this point, we now know that we already have local search completions coming out of the subject. So we actually don't need this completion subject at all anymore because that comes from local search. So we can say local search.results, and inside of there, we want to essentially just filter them, but we don't need to map them anymore because they are already that type. So we're reaching into the array of completions and filtering out the completions that don't contain a comma, and then assigning those to results. On our snapshot publisher, we need to change the type here to local search completion. Here we have this update with results. I'm not sure if this is actually called. Let's just comment that out for a moment. Fix this one up. Local search completion. And we no longer need to conform to this delegate. Okay, we're back to building, and what we've done is we've moved a tiny bit of this code into this local search interface, but more importantly, we've decoupled it behind this protocol, and we're only using a real one in the running version of the app, but when we're doing our test, we can swap this out with something new. Let's quickly run it and make sure it still works. We'll tap Add Cities, and we'll type Houston, and we can see the results show up as we expect them to. Okay, so everything is working now. Let's go ahead and add our first test that can test that particular function of Add City View Model. So we don't even have a test target yet, so let's go ahead and add that. We'll call it Weather App Tests. And inside of here, we'll create a new file, and we'll call this the Add City View Model Tests. We'll import combine and import XCTest, and we'll also need to use testable import weather app. Now we probably also need to import WeatherKit so that we have access to that interface that we're going to be using. And so let's create a class for the Add City View Model Tests, which will be an XCTest case, but I want to use that combine test case idea from before. So let's add a new file here. We'll call it combine test case. We'll import XCTest and import combine, and then I'll paste that in. Now the only thing I've added here is another assertion here to say assert publisher fails with a given error. And we can just take a look quickly. This subscribes to the publisher, receives a completion. It actually fails if it ever receives a value because we expect this to fail. And then it checks the completion. If we get a finished, that's a failure. And if we get a failure, we can check the error's localized description to match it with the expected error. And then it just waits for the timeout. So it's a similar pattern as before, but this we'll take a look at and use a little bit later. So now we've got this Add City View Model Tests. I want that to inherit from combine test case. So inside here, our system under test is going to be this view model, Add City View Model. We'll use an implicitly unwrapped optional. We're also going to need this local search, which we're going to need to create something for this. So I'm going to create something right here, and we can move it later. We'll call this test local search. That'll be a local search completer, which means we'll need a search with query. And here we can just check maybe last query is some sort of optional string, and we can set last query equal to query. Then we also have this results any publisher, and for that we can create a subject, which is a pass-through subject of the same type, local search completion array and never. And we can just create a new one of those. And then here I can just say subject.erase to any publisher to provide our results conformance. Okay, so now we have this test local search that is a dumb object that we can check to see if the query was called, and we can also send values through it. So this is going to be an instance of our test local search. So then we will override the setup function. Make sure we call super setup because that's important. And we'll create a new instance of our local search equals test local search. So the question now is, how do we set the environment up in a way that allows us to do some testing? Because if we go back to our world struct is mutable, and this means that we can, in a test, swap these out at will. But it does mean that it's a little bit dangerous, because if I say current.local search equals our local search, then every test after that is going to inherit the same object. And I don't really want that. I want our test to be self-contained and isolated. I don't want any kind of changes that we make in a test to leak out and affect other tests. So what I want to do is create a test environment that we can use in all of our tests. So I'm going to create a new group here, and we're going to call this helpers. And inside of there, we will call this test environment. So here we'll use testable import weather app. And we'll create a test environment class. And the idea here is that I want to have an array of worlds. And by default, that can just be the current world. And then we can have a static func push, which will take the current world and insert a copy of it. So let's create a copy of the current world. And rather than saying current, we could say worlds.last. Then we can say worlds.append, this new copy, and set current equal to the copy. So we'll take the last item in the worlds array, create a copy, append it, set current to be that new world. Then we're going to need static func pop, which is essentially going to say worlds.removeLast. I want to make sure, we'll say precondition here, that the worlds.count is greater than 1, because can't remove last world. So we'll say worlds.removeLast, and then we'll have to do kind of a similar thing where we'll say current equals worlds.last. And we can force unwrap because we did this check here. So the reason I want to do this is because in our test, we can say test environment.push. And then over here in the teardown, I'll super teardown. And here I can say test environment.pop. So anything that I do after this on current, I can say current.localSearch equals local search, and no other test is ever going to be affected by this instance of local search because we pop that environment later on. Finally, we can create our view model, which is the add city view model like this. Okay, let's do our first test. We're going to test that we can set the search term. We'll set the viewModel.search term equal to Houston. And then if we actually make this an array, we could just say, we could rename this to queries and make it an array of strings that is initially empty. And then here we could say queries.append query. So that way we have a list of all the queries that were sent. So then we could say viewModel.search term is Houston and then Dallas. And then I can assert XCT assert equal that the local search dot queries equals Houston and Dallas. Okay, and our first test passes. Now, this is a simple test, and that's kind of the point. We now have an object that's completely under our control, so we can add whatever we need to do to make sure that our tests are easy to write and easy to read. Let's test something else. Let's test that it filters out results that don't look like cities. Okay, so what we need here are two results. Let's say we have a Houston result, which is a local search completion, and we'll use Houston, Texas, no subtitle. And then there's another thing we might see, which is Houston has a Houston's restaurant. So if we did local search and it got Houston's restaurant like this, then we don't want to see that one. So now in our local search instance, we can send on our subject, we can send results through here. So we can send an array of Houston results and Houston's restaurant result. So if we did that, then I want to make sure that the view model results that we get assigned to this array right here is only the Houston result. So we need to do XCT assert equal like that. And it works. And if we were to add a comma here, obviously that would not work because it would treat that like it's a city. Okay, so we have a simple test that is providing that logic. So you can see how we eliminated one of those dependencies, which was MapKit. Okay, looking at the view model, we can see that the next thing we need to decouple ourselves from is CL geocoder. So let's go over to WeatherKit, and we're going to add another set of functionality here we will call geocoding. And we'll create a new file in here called geocoder. Now what we want to do is take from add city view model, we basically want to take this function and we want to convert that into a type that we can use. So we can take that and put it into this type. And so we can provide our simpler interface. If we say core location, and we'll go ahead and use combine in here as well, we'll create a public protocol for geocoder. And this will just have one function, geocode address, where we pass in the address string. And this returns in any publisher of an array of CL place marks and error. So let's create our real version of this. So this will be a core location geocoder. This will import core location and import combine. So we now have a public class core location geocoder implements the geocoder protocol. We'll need to do private let geocoder is a CL geocoder. So this will provide our functionality. We'll have a public initializer and a public func geocode address string. Now, in this case, we can cancel any geocode requests that we had before, so that this one will only have one at a time. And then we can essentially just copy and paste this code in here into here. So we'll call erase to any publisher. And I don't really want to know about this particular error here. So I'm just going to pass whatever error that we got here in this result. So what we'll end up saying here is force unwrap the error there. So if we got a place mark, we'll send back the first place mark. Otherwise, we'll do that. And in fact, sending back the first place mark doesn't really make sense for this generic geocoder. We should probably send back all of the place marks. So we'll do this. So if we got any place marks, we'll send back all of them. Otherwise, we'll fail with an error. This is now address. And we can do erase to any publisher. Now we have this assert is main thread here, which we actually don't need at the moment because we can hard code that assumption here. And not an assumption anymore. It's basically going to enforce that this happens. So we can say receive all the results on the main queue. And spinner management is going to be outside of this. So now we've got our core location geocoder. And if we go up to world.swift, we can now add another type here. This will be geocoder is some geocoder. And the real one will use a core location geocoder. So now we need to update our view model to use the new geocoder. So let's go back up here. We still need core location here because we're still dealing with CL place marks as the result type. But here our geocoder is now going to be some geocoder, and we can just return current.geocoder. So in this geolocate selected index, we still want to do all of this stuff, but we can now just say geocoder.geocode address string, pass in results.title, and we will need to set show spinner equals false when this completes. And a good place to do that is using handle events. So in receive completion, we can say self.showSpinner equals false. And because we're returning this publisher like this, our class isn't really going to hang on to this at all. So I think it's okay for us to retain self there. So at this point now, we need to sort of model this other logic that we had here of returning the first one and also mapping whatever error to this errors.geolocation failed. And in fact, we can change our error type here to be an instance of this specific errors that we want. So now what we need to do is figure out how to map the error, which in this case we can grab the error. We can maybe print it out and say geolocation error, pass that in, and instead just return errors.geolocation failed. And it will probably figure this out to be able to infer this. So let's just keep going. The next step is for us to essentially map the results that we get to be just the first one. But this one, unfortunately, will produce an optional value, and we kind of want to ignore the optionals. So we can use compact map to do that. Compact map will reach into the array, grab the first one, and if there's a value, it'll send it downstream, and otherwise it will not. So at this point, now we can take that single value that we have, which is a place mark, CL place mark, and then here we need to return a city. So we can just copy that code from down here, paste it in, and then finally erase to any publisher. And we can probably delete the rest of this code here and that code and see if it's able to compile. Okay, we're missing a return here. And that gives it enough information to know what type of error it should be returning. Okay, so we've now decoupled ourselves from core location. And it does look like this was never called, so I'm just going to delete that commented out code. Okay, so how might we test this? What we need to do is go over to our tests, and we have our add city view model tests. This test local search, I'm actually going to move this. So we'll cut that and move it over into helpers, which requires combine here. And we're going to need another geocoder here, which we're going to call test geocoder. So let's create that in the helpers group there. We'll need core location for the place mark type, and then we can create test geocoder. We'll also need to import combine and make that implement the geocoder protocol, which comes from WeatherKit, so we can import WeatherKit. And I think I need that over here on local search too, import WeatherKit. Okay, so the implementation of this one is going to be really simple because all we need to do is have a subject, which will be a pass-through subject of an array of CL place marks to send and error. Create a new one, and here we can return subject.erase to any publisher. And that is good enough for our conformance of this test geocoder. Okay, now we can set the geocoder on current to be our geocoder. And because we're pushing the environment and having a copy of it and popping it later, that's not going to affect any other tests. So now we can go over here and test geocodes selected result. So here, now that I'm thinking about this, I want this to have test geocodes selected results. Really, the result that we want is a city. So test geocodes results into city. We also want to test when geocoding fails. And we're also going to want to test when geocoding produces no results. Okay, let's talk about the happy path first. So here we're going to need a result because if you recall, when we say viewModel.geocode selected index, I need to have an index of a valid result. So let's create our results is a local search completion with the title of Houston, Texas. I can assign that to a variable that it will be our publisher. And I want to assert no failure because we're not going to generate a failure in here, and I want this to have a failure type of never. I also want to essentially create the expected city that I expect out of this. So that's going to have a name of Houston, a locality of TX, and a latitude and longitude. And I'll just use broad stroke latitude and longitude here. So Houston is roughly at 29, -95. So I'm missing lots of digits there, but this will make it easy for us to test it. Okay, so now I need to create essentially the place mark that I want to send through the geocoder. So like when you get this result, you're going to send this place mark through. And unfortunately, it's not easy to create a place mark. if we try to create a CL place mark, which requires us to import core location up at the top here, import core location. There are initializers here that I could create one, but unfortunately you can't set any properties on this. And if you inherit from it directly and override the standard initializer, it will crash at runtime for some reason. I was able to find a workaround for this, which is for us to create a test place mark, which inherits from CL place mark and takes as a initializer a place mark that comes from MapKit. So MK place mark. So again, up at the top, let's add MapKit. Actually, instead of doing that, let's take in the coordinate that we want, CL location coordinate 2D, and we'll have the title or the name of the locality or the place, and then the locality here as a string. The reason I want to do that is so that I can create a MK place mark like this, and we can pass in the coordinate like that. And then I can turn around and say super.init with place mark and pass in MK place mark as a CL place mark instead. It's a little bit weird how this works. And if I hadn't figured out this workaround, I probably would have had to create yet another value object instead of place mark that looks a lot like place mark. And at runtime, we'd use real CL place marks or wrap them in a type. And then for our tests, we could create our own value types. So what I need to do now is save the name and the locality like this. So we'll set underscore name equals name, underscore locality equals locality. Now, the reason I did these as underscore versions is because we're actually going to override the name property from the CL place mark itself and return this. And then I want to override, and we actually use this called administrative area. So that's going to be what we call locality. And because we implement this initializer, it's going to make us do this one, but we can just fatal error there. So this is kind of a weird hack that will allow us to create a place mark and pass in a few known values. So at this point, we can create the Houston place mark, which is a test place mark. And I can pass in the coordinate of 29 and -95. The name will be Houston and the locality will be Texas. So now we can use that assert publisher produces, and we want to make sure that this produces the expected city. So we've got our publisher produces the expected city. And when is it going to do that? It's going to happen when we send through our geocoder. We'll grab the subject and we'll send the result from geocoding. We'll send that as Houston place mark, and then we can send the completion event on our subject. Okay, so there are a few more moving pieces here, but we're leaning on the assert publisher helper that we created last time. And it looks like we've got a problem here because I never created the geocoder. Let's go back down here and run this test again. Okay, now let's talk about testing when geocoding fails. We're basically going to have a similar setup where we have the view model results like this. And here we can create struct some error because we don't really care what error is thrown. We just want to send an error. And here I want to say assert publisher fails with error. And I'll say publisher failing with error here is going to actually be the add city view model .errors.geolocation failed. That's the error we expect. And we're going to use the geocoder subject to send the completion failing with an instance of some other error. And what we're doing here is essentially testing that it gets mapped to this. And it appears I have a bit of a copy paste problem here because obviously we said assert no failure and then we're sending a failure. So we actually don't want that to be assert no failure so that we can actually test it. And now we test it and it passes. Okay, so now we have one other case here. I want to test when it produces no results. So we're going to go back up to this one. We will copy all of this. Then we're going to assert that the publisher produces, and this is kind of a problem that we have where we either produce a value or we produce exactly some sequence of values. Unfortunately, I can't pass an empty array here. So how do I assert that it produces nothing? Well, what I can do is take the publisher that we got and call count on it. And we want to make sure that that produces the value 0. And so here we can say geocoder.subject.send. We pass in an empty array because we got no results. And then critically, we have to call send completion and say that we finished so that count can count the number of values it got. And now we run that and it passes, indicating that we got no results if we pass an empty array. There's one final test I would like to do. Test geocoder manages, or geocoding manages spinner state. So we could say xct assert false that viewModel.show spinner. So the spinner should not be active here. Then we will again grab this so that we can create a publisher, set viewModel.geolocate, selected index 0. Here I will assert no failure, and we're going to subscribe to this like this and just ignore the value because I don't want to use, it's not an easy way for me to use this publisher here because there's no action that we're going to be doing. And I essentially want to be in control of these assertions. So then we'll call store in cancellables. So at this point, xct assert true. I want to assert true here that the viewModel show spinner is running. And then later we'll tell the geocoder.subject.send the completion.finished. Once you're finished, then this should go back to asserting that there is no spinner. So we start off false, then we get a spinner. We actually don't need that reference to pub anymore. So when we're geocoding, we show the spinner. When we're done, we don't show the spinner. Okay, and with that, I think we've tested quite a bit of functionality for the Add City flow of our application. So this weather app has a lot more functionality that could be tested. And I would encourage you to take a moment to do some of this testing on your own, using some of the tools and techniques and strategies that we've learned in the last few videos to write some more tests to exercise functionality in the weather app.